Welcome to Unit 5, Lesson 10. As we continue our study of linear equations, we have now moved into how we would see linear equations in the real world. Yesterday, we started to take a dive into where we would see linear equations, specifically slope-intercept form, in a real-world situation. Today, what we want to do is to take a deeper dive into the real-world meaning of the slope and the y-intercept. Okay, so in a real-world situation, what would each of those things mean? In order to have that conversation, we first need to talk about dependent and independent variables. The dependent variable is the variable in a function whose value is determined by the independent variable. All right? In that case, our y is going to be the dependent variable because y is influenced or determined by the value that we plug in for x. If you'll recall, y is our output. And so the output is going to be determined by whatever we put in as the input. The independent variable is the variable in a function whose value is subject to choice. We get to pick the value of the independent variable, we plug it in, we run some computations, and we end up with an output. So the independent variable is your x, or your input. All right, the dependent variable will be influenced by the independent variable, meaning that the independent variable will help us determine the value of the dependent variable. We do have one variable that is typically always an independent variable. That is the variable time. Time is typically an independent variable because remember, the dependent variable is influenced by the independent variable. If time was the dependent variable, that means that we would be able to influence time. But we can't influence time. It's always moving forward, never backward. So time is typically going to be the independent variable. Sometimes students have difficulty determining which variable is the independent variable and which variable is the dependent variable. So let's look at a situation. I am going to take a ride in a taxi cab, and it's going to cost me $5.80 for me to travel 3.25 miles. In this situation, we want to determine which variable is the independent variable and which is the dependent variable. Remember, a variable is something that we're going to measure. So in this case, we are going to measure the cost of the taxi ride as well as the number of miles that we travel. So we have the cost here, and this represents the number of miles that the car is going to travel. One way that we can use to determine independent and dependent variables is to put the two quantities or the things that are being measured into a sentence. The sentence would say something like blank depends on blank. What you put in the first part of the sentence depends on what you put in the second part of the sentence. That makes this first part the dependent variable and the second part the independent variable. Okay. So if we think about the two things that are being measured here, cost and number of miles, does the cost of the trip depend on how many miles I travel? Or do the number of miles that I travel depend on the cost? If you said that the cost depends on the number of miles, you are correct here. If the sentence idea doesn't work for you, then a second method that we have for determining independent and dependent variables is to think about the two quantities or things being measured as separate events. The event that happened first is going to be the independent variable. The event that happened second is the dependent variable. I'm not sure if you've ever ridden in a taxi before, but if you think about kind of how that scenario works for those of you that have, what happens is I get in the taxi and I say, I want to go to X place. And so I would tell them my destination. As I'm riding in the taxi and as the miles start to accumulate, I can see on the meter that the cost is going up. In this case, what happens first is I determine my destination. I'm going to travel a certain number of miles. And then at the very end, I'm going to pay the driver whatever the cost was. So the first event was I traveled a certain number of miles, and the second event was cost. That makes the miles my independent variable and the cost my dependent variable. All right, the next thing we want to talk about then is unit rate. We've been doing a really long look at, a hard look at slope, And so one other way that we can interpret slope is as a unit rate. The definition of a unit rate, it is a rate with a denominator of 1. Unit rates are often used when we go shopping. For each of the examples below, we want to identify the independent and dependent variable, and then we want to rewrite the situation as a unit rate and explain the real-world meaning using context. Here's an example from shopping. If I go to the store and I buy 5 yards of fabric and it costs me $19.95, I don't want to know how much 5 yards of fabric costs. I want to know how much 1 yard of fabric costs. The first thing we're asked to do is to identify the independent and dependent variables here. So you can think of this as a sentence. Does the number of yards of fabric I buy depend on the cost? Or does the cost depend on how many yards of fabric I buy? That's one way to think about it. The other way to think about it is as two separate events. I go to the fabric store and I pick out the fabric I want to buy. I walk up to the cutting stand and I ask the person for this many yards of fabric, and they say that will cost you $19.95. So in that case, the first event was I determined the number of yards of fabric that I wanted to buy, and the second event was I was told how much that would cost, or I would go to the cash register and then pay, right? The cost here depends on how many yards of fabric I buy. All right, now we want to rewrite each as a unit rate. Again, I don't really want to know how much 5 yards of fabric costs. I kind of really want to know just how much 1 yard of fabric costs. If you'll think about unit rates also as slope, remember that when we talk about slope, we talk about our y value over our x value. In this case, remember that y was our dependent variable and x was our independent variable. So in this case, we want to talk about the cost over the number of yards. Our cost was $19.95 and we bought 5 yards of fabric. When I divide $19.95 by 5 to get the unit rate, remember unit rate meant the denominator was going to be 1, so I'm going to divide by 5, I end up with $3.99. If I interpret that was the last step, asked me to interpret or explain the real world meaning using context. That means that it is going to cost me $3.99 per or for each yard of fabric. In our second example, it says that your babysitting job earned you $90 for 6 hours of work. To identify the dependent and independent variables here, we can either write a sentence or we can think about these as two separate events. When you go to babysit, you stay a certain amount of time, and at the end of the night, the parents come home and they pay you a certain amount of money. In this case, event number 1 is going to be the number of hours that you stay at the house, our independent variable. Event number 2 is the parent comes home and pays me a certain amount of money. So the dependent variable is going to be the amount that I was paid, because that was the second event. All right? Thinking about how my y value changes with respect to my x value, I'm looking at what is the dependent variable over what is the independent variable. In this case, I was paid $90 to work for 6 hours. As a unit rate, I would divide these out so that my denominator is 1. 90 divided by 6 gives me 15. And if I interpret that in a real-world context with context from the problem, that would be $15 per hour. That's a pretty nice babysitting gig. All right, the last two examples look a little bit different. Number 3 says that the cost of renting a computer is shown in the chart below. What is the cost per day to rent the computer? Right? So I've got the number of days here. If I rent the computer for 2 days, it's $75 and 3 days is $105. I need to determine the independent and dependent variable here. In this case, again, number of days is sort of like a unit of time. I'm going to rent the computer a certain number of days, and then I'm going to go in and pay a certain amount of money. That makes the number of days my independent variable, and that makes the cost the dependent variable. What's different about this problem is that we have 2 sets of data points. Instead of just one statement, $90 for 6 hours, we're told what happens for 2 different sets of data. And so in this case, we want to rely on the fact that this becomes an ordered pair. For 2 days, it's $75, and for 3 days, it's $105. Remember, a unit rate is just a slope where the denominator is 1. So if I look at the change here, from $75 to $105 is 30, and from 2 to 3 is 1. What that would mean, if I look at the change in Y over the change in X, is that I changed by $30 every 1 day. That means it cost me $30 per day to rent that computer. Some of you guys may be thinking, that's odd. That doesn't really work out. 30 times 2 should give me 60, and 30 times 3 should equal 90. There is another factor going on here. So besides the fact that it is $30 per day for the computer, there's something else going on here to drive that cost up. 60 plus 15 makes 75, and 90 plus 15 makes 105. So there's an extra $15 fee here in this cost, which we'll talk about when we get to Y-Intercept. But the company is charging me an extra $15 here for some sort of a fee that they're charging. Okay, the very last example, it says you jump out of a plane at a height of 20,000 feet. 40 seconds after your jump, you're now at a height of 15,000 feet. What is your unit rate in feet per second? First, we need to identify the independent and dependent variables. The two things that we are measuring here are the height of the plane, and we are also measuring the amount of time that has elapsed, in this case 40 seconds. Our independent variable would be time, and the dependent variable would be your height. All right, thinking about being able to create some ordered pairs for this, we know that after 40 seconds, we are at 15,000 feet. So that ordered pair is pretty easy to come up with. Time is X, height is Y. What would be the time here when we initially jumped out of the plane at a height of 20,000 feet? If you said that that should be 0, you are correct. We can now compute the slope. Here what happens is from 20,000 feet to 15,000 feet, we dropped or went down 5,000 feet. And from 0 to 40, we went up 40. So thinking about how my Y values change with respect to how my X values change, negative 5,000 over 40 gets rewritten as a unit rate. Divide these two things out, and you get negative 125. Now we have to interpret that. What does that negative 125 mean? It means that we fell, that's the negative part, 125 feet every second. Right? The last thing that we want to talk about is a little bit more on the interpretation of the slope in the Y-intercept. If you'll recall several things slope means. Slope in general is the steepness of a line. Okay, so do we have a tiny hill or a really large hill? Remember, on a graph, we're going to calculate that as rise over run. When we think about ordered pairs, we think about how do our Y values change with respect to how do our X values change. Now that we've talked about independent and dependent variables, we can think about how do our dependent variables change with respect to how do our independent variables change. And remember, at the end of the day, slope is just a rate of change. Okay? Our first example says that Little Caesars sells hot and ready pizzas for $5 each. Customers may use a coupon for $2 off their total purchase. The equation C equals 5n minus 2 is shown or shows the relationship between the cost, which is C, and the number of pizzas, which is N. If you need to, guys, rewrite the equation with those words in it. The cost is equal to 5 times the number of pizzas minus 2. We want to interpret the real-world meaning of the slope. In this problem, our slope is 5. Okay? Right? Recall that 5 as a fraction is 5 over 1. Recall that when we talk about slope, we talk about how does our dependent variable change with respect to how does our independent variable change. Right? In this problem, our dependent variable, or our Y, is the cost. In this problem, our independent variable, or our X, is the number of pizzas. So this slope of 5 means that it costs me $5. This line means per or for each, and this 1 means the number of pizzas. So it's $5 per one pizza. Okay. Second example, the equation h equals negative 2 over 15t plus 12 shows the relationship between a candle's height in centimeters h and the time in minutes it burns. Interpret the real-world meaning of that slope. Again, if you need to, rewrite your equation with words. Height is equal to negative 2/15 times the time plus 12. Okay. In this case, height is y and time is x. So when we think about that slope, that negative 2 over 15, remember that that is our y value over our x value. Y is our height here, and x is the time. So as I'm interpreting this, I can see that my height goes down by 2 when my time changes by 15. So what that means is that the candle's height is decreasing by 2 inches every, each, or per 15 minutes of time. Okay. All right, last thing, the Y-intercept. When we want to interpret the value of the Y-intercept, remember that that is the value of y when our x value is 0. All right, so if my x value is 0, that means that that y value is going to be either my initial or my starting amount. Sometimes when we interpret the Y-intercept, we really need to think outside the box. Why would we be paying, in some cases, paying money for something when I'm getting 0 units of that item? So we might want to think outside the box about why there would be a Y-intercept there. The first one, back to that candle. The height is equal to negative 2 over 15t plus 12 shows the relationship between the candle's height in centimeters and the time it burns. Interpret the real-world meaning of the Y-intercept. In this case, my Y-intercept is 12. Okay. If you'll recall, that is y when x is 0. Remember that y here is the height, so it's the height when x in this relationship is time. So when the time is equal to 0. Well, if time equals 0, what would that 12 mean? That 12 would be the height of the candle before it was burning, okay, or the height at time 0. So it's really the starting height of the candle. All right, last one really quick. The equation P equals 1988x plus 97,411. In this equation, P represents the total population and X represents the number of years, and it models the population of Cary, North Carolina from 2000 to 2015. Interpret the real-world meaning of the Y-intercept. So my Y-intercept there, my 97,411, remember the Y-intercept is y when our x value is 0. Well, if I think about what y was representing, that p, which is in the y position, it says that that is the total population. So it's the total population when x, which was the number of years, is 0. Okay? So 97,411 would have been the total population in what year? Well, it says that this models Cary, North Carolina from 2000 to 2015. So the 97,411 would be the total population in the year 2000.